Hello, everyone. Just to be sure that I am not, I am in the right place.
No, you are in the wrong place.
All right, everybody. Good morning. Just confirm you can hear me. And you can see my screen. I need your response if you can see my screen and if you can hear me.
Yeah, we can see your screen and we can hear you.
All right, great. Thank you so much. Okay, so during the last class, we spoke about scope. And I think callback, right? Spoke about scope and callbacks. So today we're going to be, then I think we'll also talk about the event loop, right? So today we're going to continue talking about the event loop. Then asynchronous JavaScript and closures. If we have time, we might get into promises, but the target for today is to explain the concept of asynchronous JavaScript and closures. All right. So I'm sure that for those of us who have read to any extent, you've read about JavaScript, you would have heard that JavaScript is single-threaded. All right. It has a single thread. So when you see something has a single thread, so I'm going to bring my Scally draw. So when you say something has a single thread, it just means it has one how do I put it? It has one call stack, right? It has one call stack. So everything happens in that call stack. And from our previous classes, you would realize that a call stack performs synchronously, right? That means the first to get in is the last to come out. So it follows that order, right? That's what the call stack does. It performs synchronously. So the downside to such an approach, right, is that if there is a task, so let's try to do that practically. If there is a task that is blocking the thread, so let's say we have a task that is trying to do a calculation that takes time, or you have something like a for loop, or let's do a while loop, right? So with while loops, we're going to need a count, right? Then as long as count is less than 1 billion, this is I mean, these zeros make up a billion, but get the point. So as long as count is less than 1 billion, what you want to do is you want to count plus plus. That's you want to increase count. All right. This is a while loop that's going to take a while. All right. So it's going to count for 1 billion times. And what will happen is this. Because this program runs from top to bottom, like this, and it's running on a single thread, what that means is that every code you have after it, like say you have something like console.log counts, all right? This line of code is going to wait for this while loop to run, right? It's going to wait for this while loop to run. And until this while loop is completely done, this line of code would not happen, okay? That's what we mean by synchronous. So it goes in sync, all right? It goes one line after the other, after the other, after the other. So if you happen to have an operation that is time consuming before the next operation, that next guy has to wait. That means that the thread has been blocked. So the thread has been blocked by this line of code, this while loop, all right? And every other guy has to wait for it to complete before the next thing happens, okay? So how does JavaScript deal with this problem? Even if JavaScript is single-threaded, but we also know that asynchronous programming is possible with JavaScript. So how does this happen? Like what's the jazz? There are some programming languages that, you know, they have more than one core stack. So they are multi-threaded. All right. So they have a way, if this guy is blocked, you can send just some task to this guy. So, you know, they can process in between each other like that. But in the case of JavaScript, we just have one. So how do we do it? And it brings us back to the concept of the event loop that I brought to your notice the last time. How do I even get that? How do I get that software again? I'm sure I have it here. Okay, if you have that, the tool that I sent to you guys the last time. Okay, I think I have it. Right. Yes, this is it. So let's make use of this tool. So that's where this concept comes in. This thing called the event loop. You see this guy, this circle you have here that looks like a recycler, all right? That's what the event loop does. Okay, so what happens in your code is that there are other functionalities that were built into JavaScript. Some of them were built into browsers, some into the core JavaScript, right? And then we can make use of all these other functionalities to pretend as if JavaScript is working asynchronously, like, or let me use the word to pretend as if JavaScript is using more than one thread. So JavaScript is able to do multiple things at the same time. That's how it will look on the outside. But inwardly, if you really look at it, JavaScript does not do multiple things at a time. It only has one core stack. So it's still single-threaded, right? But because we are able to delegate stuff, okay? So we send stuff to the web API, and then we send to the callback queue, and then we can now wait and check, is the callback empty? And if the callback is empty, we can now push what they have in the callback queue into the call stack, and then, you know, that is executed, okay? So it feels like, oh, this is multi-threaded, like it's a multi-threaded operation, but no, that's not how it works. There's something called the event loop that is going to keep listening. All right. So for instance, let me see if we can use this code sample that we have here. So let's just run, I'm going to pause. So you see what happened first. This set timeout function, right? I mean, it's this on function, all right? This is a function, right?
Please,
That
T, can you zoom in? Can you zoom in a bit? It's too far for us.
all right. Okay. So let's resume. Let's rerun. Sorry, I'm gonna pause. So you see this on button function. Because I zoom in now, some of those things are going to hide behind buttons, but you should get the point. So this on, this dot on, this is jQuery. That's a jQuery symbol. And this on is a function, right? So that function gets put in the call stack. Okay, that's the first thing that happens. Let me see if I can capture it. I'm going to rerun again and pause. Yes. So you see this guy gets put in the call stack. And what happens is this. Because we have said on click, all right, on click, it means that this is not to run immediately. It is to run only when there is a click. So what will happen is that it's going to be registered somewhere in the web APIs. All right. So if I resume and pause, you see that it has been registered here. All right. So anytime there is a click, it's very important. What will happen is, although this would have been more useful for the front-end folks, but it's no knowledge is lost. All right. So we're dealing with the DOM manipulations now, but I can use it to explain my concept. All right, so on the button click, this is going to be in the web APIs waiting, all right, until that button is clicked. All right, so if I resume, you see what's happening now. Let me pause. So you see what's happening. This console.log function was registered in the call stack, right? In fact, set timeout was first registered, then console.log. So set timeout had to be put into the web API because set timeout is not a core JavaScript functionality. Although you can still use it in Node.js, but it was also built into Node.js for some reasons, but it is not actually originally a core JavaScript functionality, right? It was built into the browser. That's why you see it here in the web APIs, all right? When you see web API, it is a browser-specific functionality. That's not JavaScript, all right? Very important to make that distinction. So all these functions are going to be put into the core stack. And then if JavaScript realizes that, oh, this is supposed to be for the web API to handle, it will send it to the web API. And then at the right time, that function is going to be put in the callback queue. All right. The right time for the set timeout will be when your countdown expires. So after 2 seconds, it's going to be put in the callback queue and it will wait. All right. If I'm going to use the concept of order of precedence to explain what's happening here, what happens is that the call stack has the highest precedence, right? Everything in the call stack must be done, must be completed before whatever we have in the callback queue is going to be given attention to. So this event loop is what's looping, right? And listening for the time where the call stack is empty. So it keeps checking the call stack. Are you able to receive any new operation that is not a direct JavaScript operation, if I can use that term? All right. And then it keeps going. It keeps going. It keeps going until it discovers that the call stack is empty. It will now take something from the callback queue and put it in the call stack and run. So if we resume this, You see, when the timeout is done, right, it gets in the callback queue, but then it's going to wait there until this call stack is empty. So I'm going to resume. And you see that. So did I click resume? So I'm going to resume. So you see? So it's running. All right. I think there's a bug somewhere in the code. All right. Because this callback queue will not be attended to until the call stack is empty. Okay. Until the call stack is empty. All right. So if I click this button, you see that on click has now been put into the callback queue. All right. And then if I resume, I don't know why it's paused, but so there's a bug in this code. But there's a bug in this code. It doesn't behave as expected. All right, but you get the point. It pushed into the call stack, and then it gets into the web APIs. And then that is pushed into the queue. And if there's nothing happening in the call stack, thus it is empty, the first item in the queue is pushed in. Okay, and then that's how it keeps looping. All right, it keeps happening like that. That's why it's called the event loop. Okay, so that's what happens with JavaScript. And then you feel like it is asynchronous. Why do you feel like it is asynchronous? Because you now have a mechanism to avoid long operations and allow other operations happen. Okay, so something like this set timeout now is perceived as asynchronous. Why? Because what will happen is that this function would not block the flow. So let me copy this code now and take it to my drawing board. And let's assume that we had this, all right, before the console.log. Okay, so this set timeout operation, no matter how long it takes, it would not block this next line from happening. Recall that this while loop would have blocked this console.log from happening. So this had to be completed before this, we were taking account of. All right, or before it will execute. But then with the set timeout, that's not how it happens. All right, what happens is that the console.log statement will run because this set timeout would immediately it's put into the call stack. JavaScript knows that, oh, this is for the web API. So it takes that function, registers it with the web API. And that can be happening on its own while everything in the call stack keeps executing. All right, every normal operation in the call stack keeps executing. And whenever the call stack is done with its execution, then this guy, all right, if the time has elapsed, all right, the timeout has elapsed, it's going to be put in the queue. And then, if the call stack is empty, it's going to be put back in the call stack and it executes. So it's now non-blocking. So you hear the term non-blocking. So it doesn't block. When you say non-blocking, it does not block the main stack. All right. So this is why we have the concept of promises. All right. This is how we have the functionality of promises. So what does a promise do? A promise would ensure that the main thread is not blocked. So if you have operations, all right, if you have operations that would be long, what you do is that you are going to promisify them, all right? You make it a promise so that it does not block the main thread, but we'll get to that. But before then, this would be like a slight diversion, but I need to mention this concept before we move forward. There's a concept called closures. closures, and many of you might have, come across it. Closures. So what is a closure? All right. A closure is simply a function that has access to variables in its parent scope, all right, in its parent function scope, even after that function has executed. So let me show you code. So there's a function, I'm going to call this parent. And then there's another function inside that function called child. All right. So the parent returns the child. But then the parent has a function, a variable called a is equal to 12. And then the child is going to console the log that a. All right. Now, if you look at this very well, you will see that this child function is making use of this variable in the parent scope. But we know that when a function is called, it is pushed into the stack. And when it is done executing, it is popped off the stack. So it therefore means that if we call parent, right? If we call parent is going to execute. And when it executes, what does it do? It returns child. And remember that when a function returns, it means it is done executing. No other thing after a return statement works. So if I try to console the log something, you see that even our editor is graying it out, telling you that this is an unreachable code. All right. So you see, if you hover on it, it says unreachable code detected. All right, because the return statement is the last statement in the function. If it is encountered, it means that that function is done. All right, so it returns that value and then it's popped off the stack. Okay. But then even after it has been popped off the stack, there is something that it returns. It returns a child function. That's a new function, right? But within that child function, we're making use of a variable that is in the scope of that parent, all right, that has been removed from the call stack. Okay, this situation is what we call a closure. All right. So this is a closure because this guy still has access to this resource, even after their relationship is supposed to have been over. All right. Most times when I hear the term closure, I usually um so you're in a relationship with somebody, and then even after the relationship is done, you just want closure. You just want access, some of the access that you used to have while still in the relationship. And that's what's happening here. Okay. So even after the parent function has been removed from the stack, this child function still holds on to some of those resources that it had when the relation. Okay, that's how I explain it most times. So what I'm going to do now is that I am going to pause. I'm going to pause here. So let's do something. Let's do const return child. Okay, plus parent. And I want to pause before and after line. All right, so let's try this. So you're going to see something. Let's refresh. All right. One, two. So let's see. Let's do a pause inside there. Okay. I'm getting what I want, so let's do it here. Refresh. All right. Then let's try something. So I want to show you something. I want to make the closure obvious so that you see. But yeah, so you can see now. All right. So if you look here in this scope, all right, if I expand the scope, you're going to see something called closure. Okay. And if I expand, you see that all we have access to in the closure is A12. It no longer exists in the call stack. Parent has been removed from the call stack because its execution, has been completed. What we are currently executing now is child. All right, which is this child. Okay. What we are currently executing is child, and you can see with this arrow pointing to it as the active guy on the stack. Okay. But then because of that, you see that because this child is still making use of a resource, all right, that existed in the parent, we now have closure. All right. It's a kind of we're holding on to or making reference to more than one resource. Maybe we add another variable called p equals 14, and then I'm still trying to scope. All right, because these are the things we were trying to make reference to from the child. All right, please note that simply because the variable exists in the
I can't
Hello,
hear you
T, we
clearly.
cannot hear you. In fact, way back, we cannot hear your speaker or your this thing.
Your voice is actually breaking, Mr. T.
grasp. All right, but I would request that
Hello, Mr. T.
We can't hear at all. From the beginning of that closure, can't hear like that. It's been breaking. Your voice.
you should have spoken out earlier. I'm sorry about that. Can you guys hear me now?
Sometimes your voice comes on, but it breaks away or fades away.
Can you guys hear me now?
Yes, I
Yeah.
can hear you now. Hello.
Oops.
Hello, are you still
That's my
there?
network.
Okay, I think it's going to go and come.
Can you guys hear me?
Yeah,
Yes,
I
I
can hear you
can
now.
hear you now.
So my network is poor from what I can see here, but I guess you can still hear me, have you?
Yes, we can hear you.
Okay, so what will happen is this. Anytime I go off, just let me know so that I will stop and perhaps wait for my network to be better. But I hope it's better from now on.
It's fine now, but
So-
you need to repeat some things for us. When you begin that closure, into that closure, when you're explaining it, that's when your voice started fading and cracking.
Okay, so let me go through the concept again. All right, so I said that the way I like to explain the concept of closure is using a relationship, right? I'm sure you must have heard the term outside JavaScript. Most of these terms are borrowed from other, aspect of life, and then they are used to convey a programming idea. Okay, so I like to. I'm not saying it's going to be exact, but this is something I just came up with: the concept of closure and a relationship. So, say you were in a relationship and then you broke up, but then you've not moved on. You still want some level of closeness. You still need access to some of the things you used to have, maybe night calls, visiting, going out with that person. You're trying to still, gain closure. That's the word that will be used in that scenario. All right. You're still trying to get access to some of the hold on to access to some of the resources that you had when the relationship was still, alive. All right. That's the same thing that happens here. All right. So you have a parent and you have a child. Okay. They both have a relationship going on, of course, parent-child relationship, right? And then this parent function returns the child function, all right? And the child function exists
Is it
inside.
deliberately that we are not seeing your screen?
Yeah, we're just
Wow.
about to ask that.
It's not deliberate. Too.
Can you see my screen now?
Yeah, I can see your screen.
Yeah, I can see your screen, just that your
I
voice
think
has started breaking off again.
sharing
Your
that.
voice has started breaking again.
Yeah.
You guys look and add to this networks that I have right here, because today is just very funny. But please, can you hear me now?
Yes.
All right, so let's just try. All right. So, yeah, I spoke about closure. You're in a relationship, you broke up, and then, but you still want some of those privileges. All right. You need access to some of those things you used to, have as a result of the relationship. All right. Even when the relationship has ended. That's what happens here. All right. You have a parent and a child. Okay. The parent function creates a scope, and within that scope, you have a child function inside that scope, right? But that child function is making use of a resource that exists in the parent scope. All right, you can see clearly from here. We're trying to console the log A, but A does not exist inside of the child. All right, A exists in the parent. Okay. So what happens is that this is going to form a closure. All right. Now, without this happening, no closure is being formed here. So if, for instance, this is just console login 12, all right, you will see that there's a relationship going on here. All right. But as soon as the parent is done executing and dies, the child has no business with the parents. It moves on. All right. It's not trying to lay hold on any resource that it used to have access to. It just moves on with his own life. So if we go back here, if I save and then I refresh now, you will see that there's nothing like closure happening here in the scope. All right. There's no closure here. No closure was created because the child does not mind moving on without trying to lay hold to any resource that existed in the parent. All right. So I wanted to make it very clear that because you had a child function being returned from a parent function does not mean you have a closure. You don't have a closure. All right. You simply have a parent function returning a child function. All right. That's as much as the relationship goes. Okay. And as soon as that parent function is done executing, it is removed from the call stack and it is dead and forgotten. All right. When the child is living, executing, which is existing now, we can say it's still existing, right? It does not remember anything that it used to share with the parent. It does not remember it, right? So it moves on. There's no closure. All right. It doesn't seek closure in that sense. But if it happens to be referring to any resource that existed in the parent, that's when you have a closure created. Because in the sense of, the context I'm trying to explain this concept, the child, right, is still holding on to something that it used to share with the parent, all right? So this is going to create a closure. So if I refresh now, you see that we have a closure here, all right? And then that closure, so who is this closure being, done with, or who is this, what function is this child function trying to gain closure with? Is the parent. That's why you see closure, and in curly brace, you see parent, all right? So the parent function, remember I called it parent to whatever name you call it, that's what you see in this bracket, okay? So this child guy is the child guy is the currently executing guy. So it is existing, but it still, has closure with the parent who is already gone. All right? Because it is holding on to something that they used to share while the parent was alive. All right? So that's where you get a closure from. Okay? So this concept of closure, a lot of persons will be like, oh, why do I have to lay hold on a resource that used to exist? Why not just move on or get my own variable here? All right. And then just refer to it. Why do I have to refer to this guy? Okay. So that is something that we're going to talk about in the videos that I'm going to record some videos right before our next class and post it so that you see. So I'm going to talk about that concept, all right, in the video, all right, cases where the concept of closure might be useful, all right. So if it exists in the language, then it is useful, okay? And there are going to be times where you actually need to create closures, all right? So that's the concept of closures in a nutshell, and I hope that it will help your further understanding of it. So take note, what's happening here is that this guy is being returned, and once it's being returned, it means that when you call the parent and it executes, when it is done executing, all right, the return value is going to be a new function. That's why this guy is assigned to this returned child, because this is going to be a new function after it returns. And that function, we can also call it, that's what's being called here. Okay, so just take your time, re-watch this aspect of the video in case there's any form of confusion. But I believe that with this method of explanation that I tried to come up with, it became really easier to explain the concept of closures and for people to understand it. All right. But with the
I'm
subsequent
sorry,
videos,
can I ask a question?
yeah, you can. So please hold on.
This,
Just before you go on. So I was going to make a statement. With the subsequent videos that I would record and put out there, I'm going to make this more clear and give you more practical use cases. Okay? So you can go on.
okay, because since you said there'll be more videos, I really don't understand. This return function child, if you remove this whole function block, will the code still not work? Because you're already assigning parents to returned child. I don't see what this function child is actually doing in this code.
Okay, so function child. Okay, so let me make this. Should I do that? Let me see my time. I have one more concept to quickly touch on, right? So just, I would say that you hold on for the videos I'm going to record and it will make more sense, all right? So I'm going to try to make it make sense to you. Is that fine, Rema?
All right, that's fine.
All right.
But hello, sir, I have a question. When are we expecting the video so that we can go through it before the next class?
Okay, so that is not within my power. There's somebody else who uploads the videos, all right? So I record and I send, and then somebody else uploads it, all right? So I'm going to try to make the recording ready before Thursday. All right. I'm just saying Thursday so that I have enough time, but I'm going to record after this class. I'll start recording. All right. Then I'll try to edit and then send the video over to them. So
Thank
yeah,
you.
so yeah, that's as much as I can control. All right. So let's go on. Let's talk about the last concept that I meant to talk about today, which is the concept of promises. Concept of promises. Okay. So how do we create a promise? So I'm going to just say promise 1, or say Jude promise. All right. So you use the new keyword correct. Use a new keyword and say promise. And then you're going to pass in a function to this promise, right? So how does that function look like? So let me write it separately so that it could be clearer. So you have a function and mostly anonymous. That means it has no name. All right. Functions could be anonymous. But if you want to give it a name, you actually can. So, okay. And then it is going to expect 2 arguments, all right, to be passed into it during its call. All right. One of them is resolve and the other is reject. Okay. So what you do is within this function, you can decide to reject based on any condition you want. You can decide to reject. So you could say reject, and you write anything you want to write inside of it. All right. So you say reject this operation failed. Okay. And then you resolve and say this operation was successful. Okay. So you could reject or resolve as you like. So let's comment this out and let's reject. Just reject. You can't do both of them. Immediately one of them is encountered, your function stops executing. All right. So you can't do both of them. So what you do is, let's say I'm going to set timeout here, and I'm going to say there's a function, and I'm just going to reject after 5 seconds. All right. So I'll take this promise callback and then put it into my promise. And let's see what happens. So I am going to take my promise and then I'll run it. I hope I've written something that will work. So let's refresh and see. Build promise. What's the error about? So let's see what was the error about. Go to the console, errors. Build promise is not a function. I'm sorry, it's not a function. So yeah, this is how I should call it. Dot then. So unfulfilled. This is something I want to happen. Let's just do console.log fulfilled. Fulfilled. All right, so let's try now. So after 5 seconds, we're expecting an error. So that's the error. In promise, the operation failed. All right. That's the error we're expecting. This operation failed. So you see, this operation is supposed to catch the error and then show you that error neatly. So I'm going to do console.error and say error. So I'm going to put the error out there. So let's try again. So after 5 seconds, we're expecting the error to happen. And then you see the error, this operation failed. Okay. So what if we want it to pass? So what we would have done is we would have resolved after 5 seconds instead of rejecting. We would have resolved. So we'll wait for 5 seconds. After 5 seconds, we should be expecting fulfilled. All right. So this is it. So this is promises in a nutshell. Now I'm just going to explain the concept and I will plead with you because these things are not as natural to grasp, all right? But it's very easy. All you need to do is you need to progress with me, all right, as I progress. So don't try to go ahead, or be confused. Just progress with me. Trust me, so I guide you through the process until you understand it, all right? So I'm sure you are seeing a lot of things and your brain is like, what's going on here? Okay, so just leave your brain to wonder about what's happening now. Just stay with me. What is a promise? All right, let's talk about promises in the real world. So in the real world, you make a promise, right? And when you make a promise, as at the time you make a promise, from the time you made that promise to when the promise is fulfilled or rejected, the promise can be said to be pending. So I tell you that I'm going to get you a car, all right, by the end of the month. So that cannot be said to be a fulfilled promise or a rejected promise until the end of the month, right? So within that space of time, within today and the end of the month, that promise is pending. So let me try to make this more visual so that you see what I'm saying. So this is today, right? Benny, can you behave yourself? All right, so this is today. And then today, I open my mouth and make a very big promise and say, Grandma, I'm going to get you a car by the end of the month. So this is end of month. End of month. Right. And let's just say this is a promise and also the timeline. So promise. And then this is the timeline. So what happens is that between today and the end of the month, that's when that promise is going to actually be acted upon. all right? This is pending. The promise is pending, all right? Pending, okay? And while this promise is pending, you can go about other activities of your life. You don't have to wait for the promise to be acted on before you do other things. You can't just go and sit down in your house and say, oh, I'm waiting for this promise to be fulfilled, oh, so I'm not working, and then I'm not bathing, I'm not doing the things I'm supposed to do. You go about your life and you do whatever you need to do, all right? This is the concept of promises. They create that asynchronous functionality for JavaScript, in the sense that you initiate a transaction, but other things could be happening until when that transaction is ready to happen, all right? So you make a promise, and then there's a timeline for the promise to happen. Within that timeline, that promise is said to be pending. And while it is pending, other things can be happening in the program. All right. And immediately we get to the point where that promise is to be acted upon. Two things could happen. You know the saying that says, do not put your hope in man. All right. So man can decide to do one of two things. Either fulfill the promise, the spelling of fulfill is correct. Man can decide to either fulfill that promise that he made to you or reject that promise. All right, so you can decide to fulfill it or reject it. All right. But then, yeah, so fulfill or reject. That's what will happen. All right. So promises has 3 states now. If you have been with me, 1 is pending, 2 is fulfilled, 3 is rejected. All right, as it is in real life, the fact that you have a promise doesn't mean that it's going to be fulfilled. Okay, so I've just explained the concept of a promise to you in a nutshell and the 3 states that a promise could have. All right, if you want to read about it, you can go to W3 schools and then you get a more thorough breakdown in terms of reading. But essentially, this is what happens within a promise. All right. So how do you fulfill a promise? You fulfill a promise by using the resolve callback. All right. So if you resolve, you have fulfilled it. Then, of course, this should be no-brainer. If you reject, all right, choose resolve and reject. And if you reject, it's going to be rejected. All right. But before it gets to this point, the promise will be said to be pending. All right, promise will be said to be pending. So let's come back to code. Now, this is how you create a promise. You use the new, then you use the promise constructor. All right, and then you pass in a callback to it. All right, and then that callback you passed into it should expect 2 things, which is the resolve callback and the reject callback. Those things are going to be passed into it by the promise API. All right, so it's just going to prepare for it during the declaration of the callback function. All right, so it knows that promise is going to pass me 2 things. One of them is resolve and the other one is called reject. All right, if I want to fulfill the promise, I should call resolve. If I want to reject the promise, I should call reject. Okay, so that is how it goes. So let's say
Sorry,
you're writing
Mr. T, please, can you come back with that statement?
All right, so what I said is, that this promise constructor, all right, requires that you pass a callback to it during the call. So you pass a callback into it as an argument. But that callback, right, has to expect 2 things. One of them is going to be resolve, and resolve is a callback function. And the other one is going to be reject, all right? But we know that this resolve and reject is going to be passed into the callback by the promise API. So it's not something that you construct by yourself, all right? It's simply passed into the callback that you give into this promise API, all right? Now, what am I explaining here? If you have ever done set timeouts, is set timeout the right explanation? No. If you have ever done event handlers, if you have ever used event handlers, if you are a front-end person trying to learn backend, or you have ever come across that concept, this should not be far-fetched, all right? Because when you deal with event handlers, you do something like this. You do something like, let's say button dot, so let me bring this up here. So you do something like button dot add event listener, is it? Okay. Add event listener, and then on click, and then you pass in a callback function, and you expect the events to be passed into that function for you. All right, that's the same thing happening here. This event, you are not the one who passes it in. The event listener is going to pass the events to the callback that you send to it. All right. So then you can now, within this function, you can now make use of the event. So if it's if that event is a key press or whatever, you can even make use of the target and stuff like that. All right. That's what happens. Okay. So that explanation was for anybody who has experience with front end. But if you don't, then let's come back to this place. All right. So what happens is you just declare your callback function. That's the job that you have to do. So let me just get rid of all this. So you just declare your callback function. And while you are declaring your callback function, you should know that the promise API is going to pass in two things to that function that you're declaring. All right. When you declare the function, of course, you pass in the function to this promise constructor, right? But that during execution, that this promise API will pass two callbacks to the function that you have declared. So because we know we're preparing for them, that's why we have resolve and reject as parameters, all right, while constructing this function. Then inside this function, if you wish to fulfill the promise, you call resolve, right, with any value that you want to return. So you can return 5, you can return an object, you can return a string, you can return whatever you want to return from this resolve. All right. So immediately you call resolve, what you are saying is that I am fulfilling this promise.
Sorry, your
Right.
voice is not breaking
And
again.
if
No.
you
Your voice is breaking.
fulfill a promise, what will run is the then hey. Can you hear me now?
Yeah.
Yes, I can hear you now.
Yeah.
Hello? All right. So anytime you resolve a promise, it is the dot then callback, all right, that is going to run. Anytime you reject a promise, if I use reject, it is the catch block that is going to run. All right. We can prove that now. If I save, I'm rejecting now. If I save, all right, I'm rejecting with 5. Okay, so if we check, you should see that there's an error because reject is an error, right? Reject means just throw an error. And then we're catching the error, and then we'll see 5 printed. So whatever you pass into the reject callback is what you get, okay? Even as an error. So most times you want to just either construct an error object by yourself or, just put a string and just talk about the error. So the promise was rejected. All right. Oh, sorry, I cannot fulfill this promise at the time. All right. But then if I had resolve, all right, if I use resolve, what will happen is that promise will be fulfilled. Okay. So I resolve, and then I'm saying the promise is fulfilled. All right, but yeah, you get it. It's going to show fulfilled because I'm console logging fulfilled. So I could as well get the value from here and just console log the value, and you see the promise was fulfilled. That's whatever I passed into resolve. Okay, these things are easy, but I would implore you to take time and rewatch this video. And then, like I said in the last class, you can also consult other materials online, but this is a very good foundation I think I've given. Consult other materials, come back to this video, try to compare what they have said with what I'm explaining, and it's going to begin to make more sense. But even apart from that, this is an introductory video because I know that during the time that we have for this class, I will not be able to, really explain it and give you examples that will make it make sense. So in subsequent videos, I'm going to record another video for closures and give you examples, all right, that would make them make more sense. I'm going to record for promises also and give you more examples that will make it make more sense to you. But I've explained the core concept.
Please, I have a question, please.
Promise. Yeah, go ahead, please.
I'm just thinking, in real life application, this promise, is it what happens when you program that you want a mail to be sent like in 3 hours time? Is it this thing that really takes place?
No. That's not what takes place. So you can do that using different techniques, all right? But you can do a set timeout to simulate what might be happening. All right, so set timeouts, let's say, so asynchronous JavaScript set timeout. And then this is what you want to happen. This is a function. All right, so remember I can bring this function out and declare it outside. All right, in that case, this is the function send mail. Okay, and then I'm just trying to simulate console log mail delivered. Okay, and that is it. So set timeout, I'm going to say send mail after 5 seconds. So if you check, you're going to see that after 5 seconds, we should have a mail sent, mail delivered. All right. So that could be, something that happens behind the scene. But then in programming, there are many ways to achieve a thing. All right. But this might be what happens. So you set a time lapse. And once that a timeout, and once that time elapses, your function is going to be carried out. And that function could be sending a mail. All right. So yeah.
Thank you.
Okay. You're welcome. So I'm going to give you more practical instances of when promises are used. For instance, when you try to browse a web page on the internet, or you try to call an API, you are making use of a promise because you do not know how long it will take for that page to load. All right. So it will make more sense if you use a promise for such an operation, right? Because you don't want to block the main thread. You need to understand where we're coming from, asynchronous JavaScript, and that's where I explained about the event loop, and then I'm explaining about promises now. All right. This is another way to make JavaScript work asynchronously. So you just give a promise, and everybody goes about their normal activities for the day until it is time for that promise to be fulfilled or rejected. And then we get the response. Oh, it was rejected, or it was fulfilled. And then we can do whatever we want to do with that information. All right. So promises help you, just give a promise, go about your normal activities. And then when that promise is done, just give me my result. So if I come here and say console.log after promise, you would see that after promise, actually executes first before the promise was fulfilled. All right, that's another thing I want to explain to you. It not makes sense that our promise does not block the main thread. When you give a promise, that promise is just going to, start how do I call it, materializing, and every other thing will just be happening until the promise is ready to be fulfilled or rejected. And in JavaScript, everything that happens in the stack is given priority. All right, it has the highest precedence. Remember, I told you that. So this has an interaction with the main call stack. All right, this is the main JavaScript, whatever. And then promise is a way to ensure that the thread is not blocked. So promises are always going to execute after, the normal operations in JavaScript. Okay, so I hope that you're able to get even a little from today's class, assuming that this is the first time that you're coming across these concepts. Go through the video again when you have access to it, but then I'm going to record some more videos. So this is where I'm going to end today's lecture. Well, if you have questions, I can take 2 more questions before we go. Yeah, that's encouraging. 45%. Oh, that's a pass mark. Okay, guys, thank you so much for your time. Seeing that we have no more questions, we'll end the class at this point. Thank you, guys. I'm sorry for the internet troubles.
So, Mr. K, sorry, when are we getting this video? This particular one?
Okay, perhaps you were not on the call then. I think I said it. I'm not in charge of uploading videos. I just take the class and then somebody else uploads. So I don't know when you'll be able to get it. All right, guys, thank you so much. So I just noticed that my screen is not being shared. Can you see my screen? At this time, can you see my screen?
Yes, I can see your screen at this time.
Okay, so I don't know why it's saying, okay. All right, it's fine.
Yes, you can see it.
Okay,
Hello,
guys,
Steve.
thank you so much. Were you trying to speak to me?
Yeah, I was going to ask a question. I thought you had left.
Okay, what's the question about?
Do promises use conditionals? Like if something passes, like say, okay, if a condition is met, then say the promise was fulfilled. Else, the promise was rejected.
Yeah, you can use conditionals.
Okay. Okay. Thank you very much.
Yeah, you're welcome. All right, guys, thank you for your time. Have a nice day.